I wanted to talk about something we've talked about a lot today. But first, Jacob Ideskog. I live in Sweden, and I'm the CTO at Curity. I work with identity pretty much all the time, and I know a thing or two about OAuth. And today, I'm going to talk about ghost robots and zombies. And we're going to see if we can follow the format of a sonnet. Let's see how that goes. And in a sonnet, we need to start with a prelude. So, a few years back, there was an API that was developed. Such many are. This API was needed for internal business purposes. So, a business unit had decided we need access to particular data. Please provide an API for it. However, it turned out that the API, or the service that needed the API, wasn't really internal. It was probably some SaaS service or something that the finance department, or I don't know, used. So they needed to publish this API externally or publicly for it to have the proper access. And as time went, the usage disappeared, but the API remained. So we all know what happens next, right? Someone found this API, and there was a massive exploit. Lots of data, bad data, personal data was leaked. And this is roughly what happened in the Optus data leak a few years ago in Australia. And obviously, there's a bunch of stuff here. We all know this shouldn't happen because we had an uncatalogued API that wasn't monitored. We had none, or almost none at least, access control being implemented on this API. It was publicly facing when it probably shouldn't have been. And worst of all, it was forgotten. So, yeah, a disaster waiting to happen. But here's a number that we should think about. Today, or actually 2024, the estimated number of web traffic that is API traffic is 71%. That's quite a lot. Just keep that in mind. So, let's talk about ghosts. Or more in particular, let's talk about workloads. Has anyone in here heard about workloads? Some. Okay, good. So we all know the architecture of an API infrastructure, right? We have APIs, we have gateways, we have applications accessing these gateways. That's the normal way we draw things when we draw boxes on the whiteboard to explain our stuff to anyone. Last couple of years, or not couple, maybe 5, maybe 6, maybe 7, we've changed the way on how we deploy these things, how we actually operate our API infrastructure. With the introduction of things like Kubernetes, there's a new cloud operating system. Well, it's not new anymore, but all of us aren't using it yet. And a cloud operating system is there to orchestrate everything we want to run. It's to make the life easier. And in a sense, it's democratized just infrastructure for us, because you don't have to run these things in the cloud, you can run them anywhere. You can have your Kubernetes cluster running in your servers at home even, and orchestrate stuff. That's really cool. So large-scale applications are much easier to run with Kubernetes, or any orchestration framework. So this picture doesn't really change, but the fact changes a little bit, that when we run our APIs, we run them then in workloads. That's the container around the container, if you will. And the gateway could run in a workload, the API could run in a workload, everything can run in workloads, the back end of your website, and so on. So what, right? It's just tech. But it's an interesting detail, because workloads are the processes of the cloud operating system, and we should think of them as such, and we should be aware of them. If we think about processes from a computer's perspective, what properties do they have? Well, usually you have processes because you want to run many things on your computer at the same time. Same with workloads. You tend to have that type of structure when you have a lot of stuff to run. The other thing is, well, processes are there because we want to separate different kinds of applications to share the same resource, the CPU. So they have different purposes. That's the same in our deployments as well, right? We have different business domains, different security domains. We split things up to make sure they run independently of each other and also separated from each other when needed. But I think the most interesting comparison to processes is that processes aren't static. When you start your computer, whatever runs then isn't necessarily what's going to run when you close it, because you start applications, you kill applications, you have cron jobs, you have other things that just happen. So they're ephemeral. And that means that they change. Things disappear, things come and go. And this is an inherent property of a cloud operating system, that you can spin up something, it does something, and it disappears. Another property is that they need to access each other. In a computer, that's somewhat true. The processes need to do that. You have inter-process communication. But in the cloud operating system, it's really true, because you don't have independent workloads that just do their thing necessarily. They form a bigger application together. So there's a lot of interconnecting arrows between these. And when things are communicating and we're doing it at scale, there's one thing obviously we need to know. Are you allowed to communicate across these boundaries, between these workloads, between these processes, if you will? That's important, right? So there's a word for this that's been thrown around a few times today. It's called non-human identities. We usually think AI when we think non-human identities, but it's actually bigger than that. It's just a new word for things we've done for a long time. We've had service accounts calling certain things in our infrastructure. We have machine-to-machine communications. We have IoT. I mean, there's many forms of non-human identities. It's just that all of a sudden we're waking up and realizing, hey, maybe these actually matter. Maybe we need to spend some time on figuring out which one of these are you who is trying to access this other thing. Because if we think that all of these things now in a pretty vast deployment are going to be able to identify themselves, then we need to start thinking about keys and credentials and certificates and the boring stuff that you use to identify yourself when you're a machine. And if you have a lot of these, that gets a bit hairy. Key management and credential management and certificate management, it's tricky and it's expensive, and it prohibits developers from doing stuff, because you can't publish your application, your API, or whatever you do until it has the proper credentials to access the other thing that it needs to access, right? So there's a lot of effort being put into making sure that things are secure, but also many people have to actually work to just put those extra credentials on there to make sure we know if it's secure or not. So just to clarify that a little bit, in a cloud operating system nowadays, we tend to talk about APIs here, but there's a lot of stuff now that wake up, call the API, and die. Events-driven things, or cron, like timers, whatever. Could be just, every day you need to make a report and send it to someone. That's a process or a workload that can spin up and then disappear. If we look at that thing and then we think about, okay, but this API, we did it by the book, it's OAuth protected, it needs a token in order to call that API. So what this process needs to do, it needs to wake up, call the OAuth server, get a token, and use the API. That's fine, except it wakes up, needs a credential, then can call the token server, because it needs to say, hey, I'm this workload. I'm actually allowed to call that API. Trust me. So short-lived workloads changes things for us a little bit. So why am I talking about this at all? Credentials are boring. I've said it already, right? But very soon, if not already happening in your organizations, these workloads aren't a cron job, just calling an API to make a report. They're actually agents showing up. And these agents, you're going to be a bit more careful about what access do we really want them to have at this particular time for this particular task. It matters slightly more when the non-human identities isn't just the static applications that we program that we know what they're going to do, but they're actually these LLM-powered beasts, right? So what we need to do is we need to lay the foundation now for how to deal with just the infrastructure behind everything we want to do with agents. Because if we can't even figure out who this workload is, it's going to be really hard to take us to the next level. Luckily, there's a lot of progress in this area. There's the Whimsy working group from IETF who's working on how can we just get Kubernetes to give these all identities. That works now. It's called workload identities. You can tie that into your OAuth server. You can just automatically get the identity tied to that workload, and you can get tokens flowing. Problem solved. It's very nice, but you need to spend some effort on getting there. But once you're there, credentials are for free. So it's a good foundation. You should be looking at it now, because ghosts are not going to go away. Because the next thing we're going to look at is robots. Robots are everywhere right now. We're building agents, and we talked about it throughout the entire day here, that agents aren't very useful if all they have is the model that is in the middle of them, or the models maybe. Because that's just a snapshot of knowledge and things that it already trained on, but it's nothing else, right? So at an API conference like this, we've already talked about adding tools. And tools in our world is obviously MCP APIs. Or as I just learned, GraphQL with a vector database and a few other things, also fancy. But that's what we do. So we're going to give access to this thing so that we can do something here, right? This is right down our alley. But let's stop and let's figure, what do we mean when we say this is an agent? What is an agent? Why do we even call it an agent? Well, the reason we call it an agent is because we're giving it agency. We're empowering it to do things, to make its own choices. That's a bit new, right? And take actions for themselves. That's agency. That's why we call it agents. But we know how to do that too. We've done it for 10 years. How do we delegate access to something that can take actions for itself? Well, that's what OAuth is all about, delegation. We've connected Jira and GitHub and said, hey, when there's something happening over there, create a ticket over there. I don't need to know about it. I connected you. There's some access we set up from the beginning, and it works. We've done it with CI/CD pipelines, with all over. I mean, that's what OAuth is for. And the way we talk about this access in OAuth is we create an access model. We use scopes. Scopes are just strings that explain things around the API. Or the APIs, think many. But scopes say, hey, you can list, create, delete, and modify projects. And then we say, okay, and this app over here, I'm going to allow that to list and modify projects. That's on an application level. So it's not really what the user is allowed to do, it's just what the application is allowed to do. This is still old stuff, but it's good to remember. Because in OAuth, and this is important, in OAuth, we don't model endpoints. We model access. And there's a very particular reason why we model access and not APIs or endpoints or data. That's because we want these to be understandable for humans. Because I, as a human, I'm going to have to be involved when I connect certain things. So I need to understand to some degree what these mean. And if you show me a bunch of endpoints and say, I'm going to give you this user / blah, that doesn't make sense. So that's why we model access this way in OAuth. Because when you connect certain things together, an API and an app, you could show the user this good old consent screen. And what you see on the consent screen are these scopes. Obviously, you could put some descriptions next to it and make it a little bit better. But even still, even with these strings, I can make sense out of what this actually is, right? It's pretty interesting. So this sort of raw access model description is quite powerful because it creates an abstraction between the endpoints of the APIs, the application, and it's explainable to me as a human. And obviously, in the agent scenario, we can do the same thing. This already works. There's nothing magic here. If I need an agent to work on the backlog for me, I can connect it using OAuth. I can give it certain access permissions, and I can say, you can list, modify, and create projects. Okay, we know how to do this. This is known as delegation. I delegate this access to this agent. It's a core principle of OAuth. OAuth is all about delegation. We'd call it an authorization protocol. It's not. It's a delegation protocol. I delegate an application access to act or do things on my behalf towards an API. Same thing if I do it to an agent. An agent it's just an application. It's just a bit different, right? So it will operate with these delegated privileges. But something is different, isn't it? Because if I delegate access to an app or a CI/CD pipeline, I kind of know what it's going to do. But if I delegate access to my son and give him my credit card and say, hey, can you go and buy some groceries? I think he will do that, but maybe he'll get a bright idea and actually buy some candy too, or other things. I'm not 100% sure. If I delegate access to my house so that my neighbor can water my plants when I'm away, I'm pretty sure that he will do that and that will be fine. But I'm also not 100% sure that my neighbor won't be coerced or tricked into relieving or giving that access away to someone else. So we need to remember that when we think about the robots, because they're different. They're autonomous. We have other applications that are autonomous, but they're also non-deterministic. We don't know when we ask it a certain thing if we will get the same answer twice, because they build up experience, they build up context. We had a good session about that before today, right? They build up context, so things change with them. So when we delegate access to that, it's actually more similar to delegating to my son or my neighbor than to delegate to a pipeline. And then time flies. Whoops, look at that. So context builds up in this AI agent, and I did this delegation, and OAuth was the foundation for it. And I think the question to ask as time progresses is, do we still think that the access that we gave it from the beginning is valid 1 year later or 1 week later? Is it still appropriate? We have a word for this. We call it least privilege. That's common if anyone has done a certification like ISO or SOC 2 or something like that. I mean, that's the first question. Do you follow least privilege? It's a terrible experience. But the point of least privilege is you have enough access to do your job, but you don't have more access. So if you don't need access to a particular system because it's not part of your tasks, you shouldn't have that access. That's least privilege. So it's a bare minimum, but it's also a very static way of viewing the world. Because if we give least privilege access, the thing that has to change is my tasks, then my privileges change. There's another principle in authorization that can be used instead. It's called zero standing privilege. The authorization people talk more about this one. Zero standing privilege is different because the idea is that instead of least privilege, that I always have the right amount of access, is I have no access. And when I need access, it gets elevated, and when I don't need it, it's gone. So just-in-time access, essentially, right? This is a, sorry, David, this is a pipe stream in many scenarios because it's really hard to implement zero standard privilege at scale. But you can absolutely do it in a lot of places and achieve good results. But it's a wonderful idea, and we should take that idea with us. So what I mean is this, that when we delegate access to a non-human, we should consider what points of that lifetime for that agent do we need to elevate access, and what does it take to get elevated access? Well, typically, we talk about a human in the loop at that point. I need to know, or something needs to know that there's access being requested to do certain tasks, and when those tasks are done, the access can go down. So when an agent starts, for instance, it probably needs a bit more access to build up context, but once that context is up, it probably doesn't need all of that, so we can diminish, and then later on it needs to do something again, so we need to involve the human in the loop again. That's zero standing privilege. So OAuth actually has mechanisms that can do this. The spec itself never talks about these things, but if you have designed a token-based architecture already, there's nothing preventing you from fiddling with the privileges that you issue in the tokens as time goes. So it's a good starting point to get from least privilege to zero standing privilege, or at least low standing privilege already today. And that will make both development and deployment easier. But the pace of things right now is extremely high. I mean, last year when we had Nordic APIs, MCP didn't exist as an open spec. And since then, a lot of stuff has happened, and AI agents are happening everywhere. We're building them everywhere. So I think when the pace is high, it's really important to take a step back and look at the tools that we have. Because as we've seen at this point, a lot of the tools in OAuth, in token-based architectures, in general security ideas as a whole, they can be applied to agentic security. So now let's talk about the zombies. We have our little system here. We have the agent, it's using the tool, it's working great. And we forget about it, like we always do. I mentioned pace. It's already been brought up a few times here, but not to depth. But the agent-to-agent protocols that are being discussed, they're quite interesting, aren't they? Like we think about them as, yeah, we can get a bunch of agents operating together as a swarm or as a structure of some sort, producing some result with a common goal. And the A2A protocols, they're there to facilitate that. But there's also A2A protocol discussions on how do we make not only MCP APIs discoverable, how do we make agents discoverable? Wouldn't that be nice, right? So the picture is probably not going to look like this. It's going to look like much more than this. You're going to have a lot of agents out there in your organization, outside your organization, a lot of MCP APIs, and they're going to be running. And then you're going to upgrade some of the dependencies and libraries that are there, and some of them you're going to want to have more advanced capabilities. And all of a sudden, you have A2A protocols running because you're starting to use that. And discovery was open on a few of them. And they start talking. And some of these agents get zombified. Their original purpose as a non-human is now not even a non-human. Now they're a zombie human because the intent that they were made for is now changed. Something came in and influenced them by asking new questions that they hadn't thought of before. And as we know, with the non-deterministic system, that actually changes what they do over time. So what happens when an agent asks another agent, hey, can you do this for me? This is what we should be thinking about right now, because this could cause real damages in our organizations if we don't plan for it already. This is kind of the scenario I'm picturing, right? You have the agent, it wakes up, it says, hey, I see you can list projects. That's useful because I'm trying to solve this task. Could you give me some information about this project over here? Now, we need to start thinking, is the delegation or the delegated access, the privileges we gave the now zombified agent still appropriate? Because now it's doing things that we didn't intend it to do. And what we should be thinking about is really intent. Because intent is what we're trying to authorize when it comes to AI agents. It's not pure access. It's what is this access for? And that's a trickier problem. If we take the scope model, intent is pretty hard to model with the scope model. So what we really want to know is, more. Which projects? Why do you need those? How many tickets or projects do you want to create? Do you really need to delete projects? Why do you need to delete projects? What kind of modifications are you thinking about? That's a start, right? So scopes can't do that. If you try, you'll end up with many hundred or thousands of scopes, and you'll end up with the YOLO mode. So people will just say, sure, do everything. But luckily, as been mentioned before, there are adjacent specs here that can help with this. We have the rich authorization requests, which adds a sibling to scopes. Rich authorization requests essentially mean that instead of saying create project, I create a JSON object, and in that JSON object, I structure the things that I want to be able to describe for this access. So it gives us a new tool to model access. And you can do anything you want in those. It's a JSON thing. It's freeform. The only thing that's decided is what type of authorization are you asking for. Everything else is based on that type. So you create your own schemas. And this has been around for a while, and it's not been super popular. There are a few use cases where this is really nice, but for the most part, it's really complicated to put one of these together. And the real benefit of an object like this when you're trying to ask for access is when it's dynamic, when you change things because I only need this part of access. And programming that in normal applications is usually too hard. And if you anyway are going to fill in everything every time, you might as well just use a string, which is the scope. So most people don't use these things. But an AI is actually really good at creating structured output. So structured output in the form of a rich authorization request can help us to get the AI to explain its intent. So it can say to the authorization server, hey, I want to do these things on these projects, and here's why. That's a good start. And it's not really hard for us to get there right now because we have most of this already in the OAuth infrastructure we have. The next thing, though, we should be thinking about is, okay, now we know the intent of the agent and what it's supposed to do, but how do we map that to what it actually did? That thing is a bit harder. It's similar to how we map, do we think you're a human when you're logging in? We need to look at various signals. We need to collect signals from various places and start analyzing this. So we need to get that distrust that we used to have in, are you a human, into, are you trying to do what you're supposed to do, Mr. Agent? And there's a lot of initiatives on this. The OpenID Foundation have the Shared Signals and Event Working Group, which is standardizing a number of signals that can be quite useful in this scenario. And some of them are pertaining authentication, some is account events, and others are more general. And that's a good base to build on. But the point is, all systems need to start sharing these signals for us to be able to compare. So it's not enough if the agent starts sending signals. Everywhere we need to have this. So this is bigger. And it's also a long game. Because if we're going to start looking at signals, we need to make sure all the systems have phones, because we can't make phone calls before that. So we need to build in the emitting events in more places than we probably already do. And the AI could be used to look at these, but the AI needs to send these, just as the OAuth server and the API and the gateway and all the systems in between. So if we take the lone API that we forgot about from the beginning and remember the damage. Last year I had a session on API breaches, and the estimated damage of an API breach is usually 10 times higher than a regular data breach. So that's already problematic. Now, let's imagine that forgotten API was an MCP API. Or worse, it was an agent that got zombified. What kind of damages are we looking at if we're not now taking control, using the tools we have, adding the next step, adding the step after that, and improving? Because I think that very soon we're not going to be looking at 71% of API traffic on the web. It's probably going to get closer to 100. We're going to reach the point where the internet is being run by agents for us, doing the boring stuff and sometimes even the fun stuff. And we're going to sit back. That's the situation we need to prepare for already now, because it's moving really fast. So, you need to start your preparations now. Make sure all your systems have identities, because it's going to be really hard if you don't. That's just the foundation. That we can do yesterday. We should model access for non-humans, and we should map it to something that humans can understand so that we can get humans in the loop when we need to. We need to be aware of how often we do that and plan for processes so that we don't create some sort of fatigue in that and the YOLO mode gets back in there. We need to design for intent, because that's what the AI is this, how the AI works. That's how we tell it to do things. We need to set up these phone systems so that at some point we can start analyzing the intent that we gave versus the work that was done and monitor that. And we need to be aware of the zombification. Thank you.